Hi, Mr. Sapone here, and I'm bringing you the second part of my unit video series. There will be three parts. The first part was an introduction to units, what they mean, why they're important, why they're needed, and now we're going to get down to the nitty-gritty of the situation. We're going to look at how to perform unit conversions or how to do dimensional analysis. I like to start with the rules for converting units because I like to be thorough and I like to explain to you why or how the factor label method works. So our first rule for converting units is that units cancel in division. And what that simply means is if we take something simple like a distance 10 centimeters and we were to divide that by 5 centimeters. Well, we know that 10 divided by 5 is 2. What happens to a centimeter divided by a centimeter? And if you don't know, units will cancel in division. So our final answer is 2. What I often tell my students is to think of units like you would think of an unknown variable. 10x divided by 5x equals, same thing, 2. The x's will cancel, and x divided by an x is 1. It cancels. Any number divided by itself is 1. 5 over 5 equals 1. 20 over 20 equals 1. So an x, which represents some number, divided by that same number, is always going to cancel. And the same thing happens with units. Units in division will cancel. When you divide two similar units, or two like units, they cancel. Sorry. Our next rule is that units combine and multiplication. Units combine and multiplication. Let's say we have a square and it has a length and a width of 5 inches by 4 inches. How would you calculate the area? The amount of surface area that square takes up. Some of you might know that area equals length times width. So we would take 5 inches and we would multiply that by 4 inches. Well, we know that 5 times 4 is going to be 20. But what do we do with these inches? What's an inch times an inch? And we said that units combine in multiplication. So an inch times an inch is going to be an inch squared. And that's why area is measured in square feet. And if you said, what is, like if you're buying carpet or something, I need, 50 square feet, or how many square feet is your room? That's the dimensions. What is the length times the width of the room? And it would be a similar case if we had 5x multiplied by 4x. 5 times 4 will equal 20, and x multiplied by x is going to be x squared. Same thing, just like if x was 5, 5 times 5 is 5 squared. It's the same thing. So same variable. And let me ask you a question. What will the units be for volume? Let's say we had, instead of this, let's say we had a cube. And instead of measuring the area of it, we wanted to measure the volume of it. And let's say this was 3 inches. So the dimensions of the cube, length, width, and height are 3 inches by 4 inches by 5 inches. Now you might know that volume of a rectangle or volume of a cube is length times width times height. So the volume of this, we're essentially going to have 5 inches times 4 inches times 3 inches. 5 times 4 is 20. 20 times 3 is going to equal 60. What is an inch times an inch times an inch? Well, if an inch times an inch is an inch squared, and an x times an x is an x squared, what would an x times an x times an x equal? That should be an x cubed. So the same thing's going to happen here with our units. Inch times inch times inch will be inches cubed. And that's why volume, the amount of physical space something takes up in 3 dimensions, has a cube for its unit, inches cubed. Or cubic inches, either way you want to phrase it. So units combine in multiplication. You basically add up the exponents. In division, they cancel. And what happens to units in division and subtraction? Let's look at that. And the rule says units stay the same in division or in addition and subtraction. Let's say John walks 5 feet east. Then John turns left and he walks 3 feet north. How many total feet did John walk? What did he walk? He walked 5 feet plus another 3 feet. 5 feet and 3 feet is going to equal 8 feet. We don't touch the units in division or addition and subtraction. In addition and subtraction, the units remain the same. Always remain the same. 5 feet minus 3 feet will equal 2 feet. You leave the units alone in addition and subtraction. And just to add numbers together, you must have the same units. 5 feet plus 2 centimeters. You can't do this. You'd have to convert the centimeters and feet before you added them. You'd have to keep them like that. That's just like saying 5x plus 2y. What does that equal? Well, you can't add those two together because they're different units. So you can't add feet and centimeter together in such a fashion. You'd have to convert either the feet into centimeters or the centimeters into feet before you can add those units together. So those are 3 basic rules for converting units. Units behave like x's in math class, your unknown variable. They behave just like them. So now we're asking, what is a conversion factor? We know the rules for converting units, and we're going to use conversion factors to convert them. But what is a conversion factor? And this might sound complicated. A conversion factor is a ratio written in fraction form that it can express the same value or quantity in 2 different units. Oh my, what does that mean? It might seem complicated, but it's not really. A ratio is just one number divided by another number. It's a fraction. That's what a ratio is. And you can express a lot of simple ratios. The ratio of boys to girls in a classroom. Maybe a classroom has 8 boys and 7 girls in it. So the ratio would be 8 boys divided by 7 girls. It's just a ratio. It's just a way to express a quantity. For our purposes, conversion factors are going to usually equal 1. As we're using them in order to convert from one unit into another, we're going to have to say that conversion factors are going to equal 1. And we know that any number multiplied by 1 does not change. 1,000,000 times 1 is 1,000,000. 5 times 1 is 5. So by using conversion factors, we're able to change numbers from one unit into another. And what is a conversion factor? You might be confused right now. Oh my, what is a conversion factor? Well, this is a conversion factor, a ratio. Oops, sorry about that. We have 12 inches. And how many feet is 12 inches? 12 inches is actually 1 foot. This is a conversion factor. It essentially equals 1. Is not 12 inches the same exact distance as 1 foot? 1 foot is 12 inches. That is a conversion factor. And we could write this the other way. We could say that 1 foot is 12 inches. Right? What are some other conversion factors you can think of? Well, you might know that there are 60 seconds. In what? In 1 minute. That is a conversion factor. 365 days. In 1 year, that is a conversion factor. 3 yards. In 1 foot. These are all conversion factors. 100 centimeters in 1 meter. These are all ratios that essentially equal 1. 60 seconds is the same amount of time as 1 minute. It's just being expressed in a different unit. So if we use these conversion factors, we can do something pretty cool. We can convert numbers from one unit into another. And when we start doing it, you might say, well, this is really easy. Why do I got to go through all this? But as the math gets more difficult, as the problems get harder, we need to use this factor label method. Otherwise, you're going to be reinventing the wheel or solving problems in a very convoluted and confusing fashion. You really want to use these conversion factors. And I'm sure you could probably think of a few conversion factors. What's a dozen? 1 dozen is 12. Think of eggs or something like that. So there are some steps involved with converting units, and we're not going to just spend too much time just looking at these 6 rules. We're going to look at them step by step. But you want to start with the unit you want to change. You're going to multiply it by a blank fraction. The unit you want to change goes in the denominator. The unit you want to change goes in the numerator. You insert the values for your conversion factor, and you solve the problem. Very simple, right? Now I'm probably confused like this guy down here. But let me just take you through 3 or 4 problems, step by step, slowly, and we'll implement all 6 of these rules. And before you know it, these 6 rules will be second nature to you. You don't even have to think about them. But if you need to now, I mean, it would be a good idea to write them down or to follow along or to set it up so you can get used to converting units, because I'm going to want to see all work, all setups, every step of the way as we're converting units. I will not accept a number as the correct answer. In fact, I'm really looking for the setup more than I'm looking for an answer. I want both, but it's really 50-50. I need to see that you set the conversion up properly. So let's just start by doing a problem. And I put the 6 rules here. I made them smaller. And we're going to start by asking a question. How many inches are there in 50 feet? Now, some of you may look at this. Well, obviously, there's 12 inches in a foot. I know what a ruler is. So I multiply 5 times 12. It's 600, Mrs. Spoon. Why do I got to do all these crazy, stupid rules? And that's a good question right now. But as I said, this is a simple problem. Conversions get much, much more complicated, as we're going to see. So we have to learn how to crawl before we can walk and then run. So the rule was to start with the unit you want to convert. And what unit do we want to convert? Well, we want to convert 50 feet. I want to convert 50 feet into inches. And it says for whatever reason to multiply it by some blank fraction. Okay, I made a blank fraction. I don't know what I have to put in there yet. But the unit I want to change, this is the unit I want to change. I want to change 50 feet into something else. It goes in the denominator, it goes in the bottom. So this unit, feet, got to go down here. Boom, done. The unit you want the answer to convert into goes in the numerator and the answer. So this is the numerator. What do I want to convert feet into? Well, I want to convert it into inches. So it goes in the numerator and the final answer. So this is my basic setup right now. 50 feet times some blank fraction equals blanking inches. Now it says insert the values for your conversion factor. And this is what you got to know is what's the relationship between inches and feet? Well, you should know that 1 foot is 12 inches. And the final step is to solve this problem. We know that units cancel in division. So this 50 feet, this feet, and this one, they're going to cancel because that's a division. The only unit you're going to be left with is inches, and we see that inches is over here. So I'm going to finish this problem, I'm going to multiply across, right, 50 times 12, which is going to come out to be 600. And then I'm going to divide it by 1. Now, obviously, any number divided by 1 is itself, so kind of don't have to do that, but 50 times 12 is going to be 600. And I'm left with only inches as an answer because 500 feet divided by 1 feet, or 1 foot at the end, the feet is going to cancel. 500 or 50 times 12 is 600. So my final answer is 600 inches. Now some of you might have just known instinctively, 50 times 12, done. But I want to see you show me how the units cancel in division and why this is going to become more important as we move on. This is another way to look at the problem. And I set it up with colored boxes because this method might help you solve. Whatever unit you're trying to convert, over here, this 50, the same unit has to go down here in the denominator. The unit you want to change into goes in the numerator. It also goes in the answer. The way I always tell my students, the unit that's on the top got to go on the bottom. Unit on the top, bottom, top, bottom, top, bottom. Unit on the top goes on the bottom. I always try to make them remember that. Just start the problem off like that. Take whatever you're converting, make a blank fraction, and put that same unit on the bottom. The unit you want to go into goes in the top and also over here. So 50 times 12 over 1. Again, these feet are going to cancel because it's a feet over a feet or a foot over a foot. You're just left with inches, and that's how we solve that. And let's do the opposite problem now. Instead of converting feet into inches. Let's convert inches into feet. And again, you might say, well, I just got to divide by 12. This is relatively easy. That is true. But how are we going to set this problem up? And again, first thing we want to do is take our 744 inches. We are starting with the unit we want to change, 744 inches. We are multiplying it by a blank fraction. And again, I color coded it. We know that the unit that goes in the top got to go in the bottom. The unit you want to change goes in the denominator. The unit you want to convert goes into the numerator. And then it says to insert the values for your conversion factor. What is the relationship between feet and inches? This is our basic setup right now. We know inches here, feet here. What is a conversion factor? Well, we know that 1 foot is 12 inches. You don't always put the 12 on the top. You have to look at what you're doing. You're going to put 1 feet is 12 inches. And that's our next step. So now, how are we solving this? We're multiplying across. 744 times 1 is 744. Now I have to take 744 and divide it by 12. 744 divided by 12, the inches cancel. Because we have units in division, and that's what they do. They cancel in division. And we get a final answer of 62 feet. Hopefully so far so good. This is a basic setup I made for you. I'm hoping that you can basically maybe write this down in your notes or color coordinate it. Use a pen and a pencil. Maybe use one box, a square box, one a squiggly box. Somehow get used to setting up your problems like this. The unit you want to change always goes in the top and the bottom. And the unit you're changing into goes in the numerator and your final answer. So you always start with the unit you want to change. You start with that. Then you put it at the same unit in the bottom. The unit you're changing into goes in the top and the final answer because that's where you want to end up. Then you just insert your conversion factor. This is the basic steps to solving units. And if you follow this process, you will do absolutely fine the rest of the way. If you get lazy and decide, I'm just going to divide by 12 and multiply by 12, and you think you're going to get away with that, it's going to catch up to you really, really fast. And let's do a couple more. We're just going to do a couple more practice problems now just to get used to doing it. That's what the rest of the video is. There really isn't any new material. Just going to be a couple sample problems. And I encourage you to even pause this video right now. Maybe try this before I do it. Follow along with the steps. And again, I put in this blank setup for you. Sorry about that. And I'm going to basically solve this. And you want to get in the habit of doing this. Start with the unit I want to change. Well, I have minutes, right? That's the unit I want to change. I have 40 minutes. That unit also has to go down here. What do I want to change into? Well, I want to change into seconds. I want to change into seconds. And I know that I have 40 minutes. The problem tells me 40 minutes into seconds. What is the relationship between seconds and minutes? Everyone knows that there is, or 1 minute is 60 seconds. So how am I solving this problem now? Well, I'm going to multiply across. Right? 40 times 60. And I believe that should be 2,400. Yes, 2,400. These minutes are going to cancel. 40 times 60 is 2,400. Divided by 1, it stays at 2,400. Multiply across, divide by the bottom number. Do that in every step, whether there's a 1 or not, just to get used to doing it so you don't confuse yourself. And I have an answer of 2,400 seconds in 40 minutes. That's how many seconds there are in 40 minutes. Another problem. How many cups are in 4.5 gallons? How many cups are in 4.5 gallons? And you might not know how many cups are in a gallon, and that's fine. That would be something you would look up on the internet, or you look up a conversion factor, or Mr. Spoon would give you a conversion factor on the test. Some you should know, you should know there's 12 inches in a foot. You should know that there are, 12 objects in a dozen, 12 eggs in a dozen. If you had a dozen of eggs, you have 12, things of that nature. Time, feet, you should know basic ones. But how many cups are in a gallon? And I'm going to do this out. Start with the unit you want to change. Well, I have 4.5 gallons. And I know that I have to multiply it by a blank fraction. The unit I want to change goes in the top and the denominator, so I know this is going to be gallon. I know the unit I want to convert into is always going to go in the top. Sorry, I flipped the slide on you. How many cups are in 4.5 gallons? We're on this problem. We have gallons, gallon, and I want to go into cups. And I know my final answer must be in cups because that's what I want to convert into. So the only thing you need to figure out now is how many cups are in a gallon. And there are 16 cups in 1 gallon. And I believe this final answer, 4 times 16, is going to be 64, and 8 is going to be 72. There should be 72 cups in 4.5 gallons. 4.5 gallons will have 72 cups of water. That's our final answer. Why? Because units cancel in division. Units cancel in division. 4.5 times 16 is 72. 72 divided by 1 is still 72. So that is our final answer. And now we can go ahead to the next problem that we kind of skipped to. And this problem asks us, how many eggs are in 15 dozen? And I encourage you to try this yourself before I do it. Set it up. Make sure you can do it. And I'm going to go ahead and do that for you now. Pause me. If you need to, pause me. Pause me. So we have 15 dozen. And I know I got to multiply it by a blank fraction. Same step all the time. The unit I want to change, got to go in the denominator. The unit I'm changing into goes in the numerator. And the final answer, eggs. How many eggs are in a dozen? Well, there are 12 eggs in 1 dozen. So again, the dozen's going to cancel. 15 times 12, 15 times 10 is 150, and 15 times 2 is 30. That's 180 eggs. And 12 dozen. Again, use your calculator if you need this. 15 times 12, that will be 180. 180 divided by 1 remains 180. Final answer, 180 eggs. 180 eggs. So again, same process. And just to flip it, how many dozen is 89 eggs? And again, if you need to, pause me, practice it. I encourage you to practice. 89 eggs. Times some blank fraction. This should be getting old by now. Eggs goes in the bottom because you have eggs in the top. Dozen goes here. Equals. Final answer, because these eggs are going to cancel, is going to be dozen. Units cancel in division. And 1 dozen of eggs is 12. 1 dozen of anything is 12 of that quantity. A dozen of apples is 12 apples. So now we have 89 divided by 12. I actually don't know 12 divided by 89 off the top of my head. Roughly 7.5-ish, somewhere around there is what I'm going to guess. Approximately 70, what do we say, 7.5 dozen. Roughly 7.5 dozen. So that's going to be your final answer. That's my fault for not picking a round number, but roughly around there. If you put that in your calculator, you're going 89 times 1 is 89. 89 divided by 12. So you take 89 divided by 12. And you'll get an answer very close to this. If you had a calculator, you get an exact answer. I don't have one in front of me, and I don't want to stop the video for that. And now we have one problem. This problem's a little more challenging. How many seconds are in 3 hours? And actually, yeah, we'll do that one now. Actually, we'll skip that one for now. That's going to be our final problem. We're going to end with that problem. A swimming pool holds 10,000 gallons of water, and 1 gallon of water weighs 8 pounds. What is the weight of the water in the pool? Now, this one sounds a little complicated. Think about it. Try to solve it before I do it for you. What does the swimming pool hold? Well, it holds 10,000 gallons, so I know that the unit I'm starting with is going to be 10,000 gallons. I know that the unit that goes in the top must go in the bottom. Gallon. What is the weight of the water in the pool? They're asking me to calculate the weight of the water in the pool. So I know my final answer obviously is pounds. Same unit here, pounds. That's what I want to convert into. I want to convert into pounds. What is the relationship between a gallon and a pound? This is something you'd have to look up. And I'm going to say it's roughly 7 to 8-ish. I'm going to say 1 gallon is 8 pounds. That's not exact. But if you knew the exact conversion factor, you would get an exact number. How would we solve this? These gallons are going to cancel. Again, you're going to multiply 10,000 times 8. It's going to be somewhere around 80,000. Again, 8 is not the exact calculation. It's 7 point something. But roughly, this is the process. It's the process that's important for you to learn right now. Conversion factors, we can look them up at any time. We need to know how to convert units from one unit into another. And this is the process by which we do it. Multiply across, 10,000 times 8. 80,000 divided by 1 is the same number. The gallons cancel. We are left with pounds. So again, that's how our unit conversion goes. And here for our final problem, this one's slightly more challenging, and I don't think I'm going to solve this one for you. I'm going to kind of tell you how to solve it. And we'll look at this in the beginning of the class after I give you a couple short questions to make sure you watch this video. And basically it's asking you how many seconds are in 3 hours. And let's kind of just set this up first like we would. We would say, well, I have 3 hours. Okay. 3 hours times. And if hours is there, we know hour got to go here. And the unit I want is seconds. And that's going to equal, obviously, seconds. The unit we're converting into. We would set this problem up like this. 3 hours times seconds per hour equals seconds. This is basically how you set this problem up. The unit you want to change goes in the top, it goes in the bottom. The unit we're going into goes here and here. But generally, most people aren't going to know how many seconds are in an hour. I mean, how many seconds are in an hour? You might be like Mr. Zapone and know that there's 3,600, but most people generally don't know that. So what you may have to do in some problems like this is you may have to first convert hours into minutes and then convert minutes into seconds. So how many minutes is 3 hours? And we can say 3 hours times, minutes per hour going to equal minutes. Hours are going to cancel. There are 60 minutes in 1 hour. So you multiply 3 times 60. That'll give you an answer. There's 180 minutes in 3 hours. Now what you do is you convert 180 minutes into seconds. Start over again. You have 180 minutes. So now we go to the next part of the problem. 180 minutes times blank. And I guess I am going to do the problem for you. Maybe not the whole thing, but this is generally how you do it. A two-part problem like this, you have to convert 3 hours into minutes, then take that value in minutes and convert it into seconds using the same general process. And I'm going to ask you a lot of questions like on your 16th birthday, how many seconds will you have lived? And there's going to be quite a few multiple part conversions like that. And you're going to have to do some of these. I might ask you, a clock goes from 1:15 p.m. to 3:30 a.m. How many seconds went by? How many minutes? You're going to have to do some problems like that. Problems can even get more challenging. Miles per hour into feet per second. You have to convert miles into feet and hour into seconds, all in the same problem. So there'll be a lot going on. So these things are going to become more difficult as we move along. But for now, hopefully you have a semi-decent understanding of how to convert units using the factor label method. We again start with the unit we want to convert, multiply it by this blank fraction. Unit that we want to get rid of goes in the top and the bottom over here, and the unit we're converting into goes in the numerator and the final answer. And units cancel in division. So this is Mr. Zapone. I'm out.